podcast of the Multidisciplinary Research Center, and today we are doing an extraordinary podcast with our guest, Dr. Aleksander Rečnik from Ljubljana, from the Jožef Stefan Institute, on the occasion that he got the Pannonia Award from the university for the collaborations that he has with our university. So Aleksander, welcome to the show.
Thank you.
And instead of me introducing you, please tell us something about your work. I know that you graduated as a chemical engineer, but your actual research is different, I think, now. So please tell us what you are doing mostly.
So after my master's studies in chemical engineering, I moved to material science department at Jožef Stefan Institute in a group of Professor Drago Kolara.
So you work in material science,
Yes.
and you look at defects, boundaries in many types of materials. Actually, your institute, the Jožef Stefan Institute, is well known for these types of research lines. Am I right?
Not particularly. So we have departments which are related to material science, but there are strong physical science departments, robotics, fundamental chemistry, biology. So it's a multidisciplinary research institute, but it was based as nuclear institute in the time of Yugoslavia.
Well, for me, this institute of yours brings many good memories because we visited you several times.
So again, I think you always brought interesting topics to study. You wanted to get some answers on some phenomena, and this is also my point of view to science, that I always want to find solutions to crystal growth, to replacements, from which we can learn something and use synthesis of materials.
Okay, so it was the topics that we brought. That sounds good.
And the discussions. So I remember when you brought your two PhD students, and we did a lot of work on TM, and then we went to Mežica mine for a few days, and in the evening we had intense discussion about the results and wrote outlines on a paper on the desk in the restaurant for 4 papers, I think 3 of which we actually published then after that. So this was a very productive evening.
I was asking these questions not particularly because of us, I mean to discuss our particular group, but these podcasts are meant to be useful for people who watch and maybe to provide some good practices. Well, you just gave an example for one of these good practices. But you go together to have dinner in a restaurant, and then you scribble outlines of papers while you are having dinner, and that turned out to be really successful in our case, because at least 3 papers came out of that evening.
Yes,
as far as I remember.
This was not writing text and introduction and things like that, but we were sketching and drawing figures, because from figures then you get a picture of the paper, then the text you fill in.
Well, I know that you wrote books about the minerals of Slovenia, which is a little bit, seems to be remote from the material science topics you work, but actually they are not. So how do you think your hobby is collecting minerals? You are well known among mineral collectors as well. So how does your hobby fit in with your professional work? Is it useful for your professional work?
So starting from studying planar defects like twin boundaries and other type of defects which are triggered by some chemical deviation, dopants, I saw similar things in minerals. So very often we see twins, we see twisted crystals, and it's quite interesting how they form. We see replacements of minerals which are oriented, and very interesting to understand what happened, what processes were behind. So these are the challenges which I think nature thought of very find ways how to adopt crystal structures to compensate for some change in growth conditions. So some elements can have no effect on the growth of crystal, and some elements trigger the structure to make a different stacking, and then we have a twin boundary or a twinned crystal. And interestingly, these twinned crystals are always larger than the single crystals in the same pocket, same environment where they grow. This is also interesting things, why they would grow faster. Are they more favorable for growth than the single crystals? And things, questions like this, which we have no answers yet. For some minerals we do, but there are many things which are interesting to solve.
So is this research mostly fundamental research, or does it have any applied aspects as well?
So in the first place it's fundamental. We want to understand at atomic scale what happens, why some twin boundary forms. But in the end, whatever you do to the crystal, it changes its physical properties. So in our studies of spinel, where we found that we can generate them with the addition of beryllium oxide, we found that spinels with twin boundaries, which can be produced in multiples, not just a single boundary, are much tougher than the regular spinel. And spinel ceramics, very dense one, is used as protective glasses for watches and armory. And now we developed a patent with a group in Turkey, where they have a company, they will produce spinel ceramics based on twins.
Oh, excellent. Yes. Congratulations.
Yeah, this is just a side effect.
Side effect.
I'm more interested into atoms and how does it work.
I know that you have lots of international collaborations with other groups as well, in Germany, Austria, in Russia. And can you please tell us something about these international collaborations, that in general, what do you think is useful when you collaborate with people in other places of the world?
So definitely science cannot be closed into some closed community. You find people with whom you can collaborate, discuss, and solve some common interesting problems. I started to go to other research groups already during my PhD studies. My advisor advised me to go to Stuttgart, to Max Planck Institute, where I spent almost 2 years. At conferences you meet interesting people and you collaborate with. So I collaborated with colleagues in Japan, United States, Russia, England, but this doesn't mean that these particular countries should be visited for that. Israel as well, Russia. But I found people there who worked on similar problems, and it should be no limit for that. Yeah. I think.
I agree. Science is really international. Well, congratulations again on your award, and thank you for all what you did for our university and PhD students, and we hope that we can continue this collaboration in the future.
We definitely do.
And have a good time while you are in Hungary.
Thank you.